This is our formal lab about air viscosity. So what is being investigated? So what we're trying to investigate is how velocity affects the viscous force of air on an object. In order to test this out, we needed to use the force of viscosity equation and all the given values that go along with it, such as the values for viscous force on air. So our experimental plan was to drop styrofoam bowls from the height of 1 meter down to the ground in time to see how long it took for them to each reach the ground. And we would vary this by adding extra weight. So we would do 1 bowl first, and then 2 bowls, and then 3 bowls, all stacked together, and see how the time changed for each trial. As you can see right here, we have a system schema and energy diagrams. And as you can see in the energy diagrams, the energy of the system is being lost due to air resistance. So the goal of our experiment was to be able to determine and describe how velocity affected the viscous force of air, and in doing so we were able to make a statement on the relationship between mass and viscous force. Increasing velocity will also increase the amount of viscous force falling on an object through air, and we're able to control the increase in velocity by increasing mass. So therefore you can make a relationship between mass and viscous force in a free fall situation, given that the radius is held constant. So here's our hypothesis. We hypothesized that increasing velocity will increase the viscous force of air. Here we have all the graphs showing the velocity and kinetic energy for each of the trials. So this is for the first bowl, and this is for 2 bowls, and this is for 3 bowls. And we used the calculations for the velocity that we were given from the tracker data, and we were able to input it inside the equation and get values for the force of viscosity. And what we found was that the trial with the lowest velocity had the smallest force of viscosity, and on the other hand, the trial with the fastest velocity also had the fastest and the largest force of viscosity. This data supports the relationship between velocity and force of viscosity shown in the equation for the force of viscosity. This concept is applicable in a very big area of engineering, which is aerodynamics. So as the force of viscosity increases on an object that moves with a higher speed, resulting in greater air resistance acting on the object in the opposite direction of the applied forces. Therefore, if one wants to adjust air resistance on an object to make it, say, more or less aerodynamic, you can change the physical properties of it given in some of the equations such as radius. In conclusion, our experiment shows that for a falling object, mass and velocity are indeed related, and the relationship between these variables was used in our experiment to help us to understand the viscous force of air on styrofoam bowls. The data shows a positive correlation between the magnitude of the viscous force and the velocity of the falling bowl. We believe the relationship between mass and velocity can be explored further in other experiments to fully develop a working relationship between force and mass.